I'm not here to teach you how to be a cloud network engineer, but I think I need to teach you how to be a cloud network engineer. Information security's origins are in network security. It's still one of the bedrocks of our profession, even though there are many newer career paths that never involve touching a firewall. But if you think about cloud computing, one of the essential characteristics is that we do everything over a network. So, why network engineering instead of just talking about security features? It's simple. Your network design will profoundly affect your network security. Unlike a physical network, with cloud, we have way more capabilities to tune our networks at no additional cost for better security design. In the Journey to the Center of the VPC lesson, I introduced a bunch of concepts around software defined networks, just SDNs, and how Amazon's implementation, which is the mighty VPC, functions. With that intro out of the way, I want to cover a networking fundamental and internet gateways before we start building the basic VPC by hand, which we're going to do today. As we go through the lab part, I'll explain each component with a focus on the minimum required elements, but I want to give you a little bit of background first. And we're going to start that by talking about classless interdomain routing, CIDR, and yes, we just call it a CIDR. This is the standard notation we use to describe and define networks and subnets. So when you see 192.168.0.0/16, that's CIDR notation. You can read about all the details over on Wikipedia or somewhere, but I'm going to give you a little bit of the short version because we're going to be using that a lot as we build out. Let me go ahead, pull the whiteboard up for some of this. It'll make it easier to visualize it. So CIDR notation defines an IP address range, and it consists of two parts. So the first part is the IP address. And in this case, we're going to go do it with 192.168.0.0. Then there's a number after it. And in this case, it's going to be a /16 for our example today. That combination defines how big the network is and which IP addresses it managed. So in this case, this is what we call a class B. Whoa, that was not the symbol I meant to put in there. Okay. Dump. Okay, so this is what's known as a class B network. And a class B network has a little over 65,000 internet IP addresses associated with it. 65,536 to be precise. And the range that's covered. So that 192.168.0.0 means it covers the IP addresses 192.168.0.1 all the way through 192.168.255.255. I think I got that right. So that is what gives us that IP address range. Now, on the other hand, that same notation can refer to a single IP address. Let me change colors here to make this a little more interesting. And let's go with a blue. So 168.2.5/32 is a single IP address that refers to your computer. And there's other ones that, and if you look online, you'll see what the IP address ranges are. But for example, we commonly will use like /24s or /26 to delegate subnets. So you're going to see in a minute when we get into the lab how we use CIDR notation as we're building out our VPCs and as we're defining our subnets. This is just so you understand what we're actually typing into the fields. Now, these are all IPv4 examples, but there are also options that it'll work with IPv6, IP version 4, IP version 6, and we're not going to worry about that too much today. Okay. Now, there's another thing you need to know, and you don't even remember the name for this. It's called RFC 1918. I think there was like a big flu then. Maybe an interesting choice. And I mentioned it briefly last week. But this is a standard set of addresses that we use for private networks. These are internet addresses that will never route over the internet, or they're IP addresses that will never route over the internet. They will only work on a local network, and they're only private for your network. So what if something with one of those addresses needs to talk to the internet? Well, that is network address translation, and we're going to cover that probably in the next lab. There are three blocks of private IP addresses that we have available to us. And those are, let me move my little whiteboard around here. So the first one is 10.0.0.0 through 10.255.255.255. Obviously, this is going to be the biggest of our three options. The next, and this is the one that Amazon tends to default to with the default VPCs, 172.16.0.0 through 172.31.255.255. And then the last one, and again, or I'll go over this in a moment, is 192.168, like my example above, .0.0 through 192.168.255.255. And because of the way networking math works, we never have a number bigger than 255. So that's one of those limits. This one here and this one here, odds are, that's what your home IP address range is. That's what most home routers end up being, one of those two. You have probably seen those. Remember, those don't route to the internet. We're going to use both the CIDR notation and these private networks in like 2 minutes when we actually get into the lab part. Okay, let's move a little bit. And I'm going to change my whiteboard so a little bit slightly. Let's move off to the right here and talk about internet gateways. So as we talked about last time, VPCs are a software-defined network, and all the packets are wrapped and shipped around using Amazon's internal software on Amazon's internal networks. But hey, at some point, we want to, talk to the internet, and the internet still uses the old school regular networking standards. So how do we pull this off? Well, we're going to use a special construct called an internet gateway. Now, I don't know if it's software, if it's hardware. I mean, I'm sure it's a combination of both, but an internet gateway is something you attach to your VPC that connects you bidirectionally to the internet. Internet gateways connect your resources in a VPC to the internet, and it handles translating from the software-defined network to the regular internet. With a regular internet gateway, we can assign public IP addresses to our resources. And this includes instances, Amazon's term for virtual machines, via their network interface. In Amazon, that's going to be an elastic network interface, which is like the virtual hardware that pretends to be, a network plug that is sitting in the back of your computer. And by default, these are all IP version 4 public IP addresses. Yeah, you got to pay a little to use those. And it's all within a massive number of internet addresses that AWS bought and owns. You'll get a random address from the pool, and it's going to change every time like you shut an instance down and you start it back up, unless you pay more money to have a permanently assigned one. And so real quickly, going over to the whiteboard here, if I imagine that I've got Amazon, this is my VPC, then I'm going to have the internet gateway is going to be sitting somewhere over here, and then that's going to connect me to the internet out here. And if I have an instance in my VPC that wants to have a public IP address, so not one of those internal ones that we were just talking about, it's all of its communications are going to go between the internet gateway, and that's what's going to handle translating and routing that traffic into the VPC, into Amazon's SDN. So they're really cool. They track and translate these software-defined resources in Amazon, in AWS, and handle all the wrapping and the unwrapping of the packets from the VPC itself in Amazon's native network back to the internet itself. How does it do this? Magic. I'm pretty sure it's magic. In my head, I picture like unicorns and hamster wheels, and I may need some professional help. Okay, real short lesson today, a few key points. CIDR, CIDR notation, is how we define the internet address ranges of our networks and our subnets. We're going to use this a whole bunch in all of these networking labs. RFC 1918, and you don't need to remember the number, but that sets aside 3 address ranges that we can use for private networks, and we always are using a private network to some degree within AWS. And internet gateways connect our VPCs to the internet and allow us to assign public IP addresses to our resources. We're actually going to get into that network address translation which means we can have resources with only private IP addresses that can talk to the internet, but nothing in the internet can talk to them. But I'm getting ahead of myself, and let's go jump into lab and actually start building this. Today, we're just going to create a bare bones VPC. We're going to do the VPC itself. We're going to do 2 subnets, and we're going to do an internet gateway. This is just enough to get us started. Let's go into the console and go to VPC. As you can see, we don't have any VPCs because we deleted it last week, our default VPC. Let's go over to and just click the button right here, create VPC. Okay, now Amazon is defaulting to VPC and more. This would do all the work for you and create all the subnets and all the route tables, kind of like we could do with infrastructure as code, except Amazon's doing it itself. And I don't like things to be that easy. This is our chance to get into the plumbing. So let's just do VPC only. And we can apply a name tag, and I do like to use these all the time. We're going to call it Cloud S.L.A.W. That's my way of just getting free marketing out of all of you, since in all of you, you're going to have Cloud S.L.A.W. in your accounts. Then we're going to get to our address block. The address block we want to use, it's going to be an IPv4 address block with manual input. We're not going to bother with these other more advanced settings that are things we don't necessarily need. We're going to go with a /16 network, and let's stick with that 10 address range. 10.0.0.0/16. This is going to give us a full Class B network to work with. We're not going to worry about IPv6. When we get to that point, we're going to create separate ones. We're going to stick with default tenancy. If we go to dedicated, you get all your own hardware. You don't have to share with anybody else, and it's going to cost you a lot more. So we're not going to mess with that. And you can see that the name tag was applied. Let's go create VPC. Name tags is actually how most things are named in AWS, unless it's something like an IAM. It may not be an actual tag. It might just be a definitional part of the resource. Okay, so the VPC is created, and there's 3 pieces here that we have to talk about that Amazon created for us. Now, we can ignore this. So it's not a default VPC. We talked about that. I don't like having those because then anybody can launch anything. It'll automatically go in the default VPC. We're not dealing with address use metrics or tenancy we talked about. We have our IP address range. We're not doing any of the DNS firewall stuff. We'll deal with that later. DNS host names, we'll deal with that later. The things that matter that Amazon created is this DHCP options set. I'm going to open this very quickly in a new window to show you what it looks like. And that basically defines what domain names are going to be used. So that stands for Dynamic Host Configuration Protocol, and it's going to give you like internal domain names that can refer to things instead of just IP addresses. It's required to have one of those. Amazon will create that for you. If you are creating it manually via infrastructure as code, when we get to that in a couple of lessons, you'll see what it looks like. Okay. The next thing we have is the route table. We're going to explore the route table in a bit. We don't need to get to that today, but you have to have a route table. So Amazon automatically created that for you. If you try and do this by command line and you don't specify one of these, you'll actually get error messages. You just have to have a route table for that VPC. It's required. And then we have our main network ACL. Now, ACLs are a bit of a funny beast. ACLs stands for Access Control List, and it's a way of controlling network connections. And be like, hey, didn't you say there's a thing called security groups that'll do that? Yes, security groups are the primary way to do this, but ACLs are baked into the lowest layers of VPC and of the subnets. And so by default, the default rule is allow anything in, and then there's a backstop rule that says deny everything. And how does that work between both of these? That's because this rule is evaluated first. I'm going to allow the traffic. This rule is evaluated second. It's very different than how security groups work or any of our identity and access management. We have inbound and outbound rules. So in this case, it's wide open. I'll tell you what, I don't use ACLs like almost ever. There's are some use cases that we're not going to get into for quite a while with ACLs where you do want to consider using them because it can control access space at the subnet level as opposed to security groups, and you can't apply a security group to a subnet. I'm getting ahead of ourselves. I don't want to confuse you. For now, just know we're not going to be using ACLs for a while. You only need them in specific use cases, even though a lot of your security tools might tell you, oh no, you've got a default ACL. Don't worry about it. You don't need to modify these in the vast majority of cloud networks that you build. You will do it in some cases, but not in a lot. Okay, so those are the three pieces that AWS built for us. Oops, I meant to close that out and close that out on the VPC. But you'll notice we have no subnets, no network connections to other networks. So let's fix that. So I said we're going to create subnets, and I want to create 2 subnets for today. We're going to make these our public subnets, and we're going to learn a little bit about the availability zones. First thing we have to do is pick our VPC. We only have the one VPC, and we have to name it. And so let's go, actually, let's be better about our naming. S.L.A.W public1, because this is going to be a public subnet. Availability zone, we want to pick it. And the one we're going to pick, just pick 2A or 2B. It doesn't really matter. These all kind of map a little bit differently for everybody. We're just going to make sure that as we make 2 subnets, they're both going to be different. And then the IP address range, well, we don't want it to be all of our IP addresses. That's the base IP address range of the VPC. And now we can actually create our subnet addresses, 1.0.1.0/24 is a good start. And you can see that that's a subnet with 256 IP addresses. Kind of nice for them to do the math for us. Our names there as a tag, we're set. Now, from this page, you notice Amazon's being really nice with the user interface, and it didn't look like this last time I did this by hand. I usually use infrastructure as code. I can click Add New Subnet. Now we have a second one. And so S.L.A.W public 2 is going to be the name for this one. We picked 2A for our other availability zone. We want 2B for this one. Remember, subnets map directly to availability zones. And this allows us to create resiliency in our network, because if one availability zone goes down, the other one will stay up. Now, at the start, we're just going to deploy resources into one of these. But as we go forward in time, we are going to start deploying resources that span availability zones, probably pretty quickly when we get into load balancers. Okay, so the IP address range we want, let's go with 10.0.2. Yeah, I'm real creative. .0/24, and my math is correct. I have 256 more IP addresses. Just to show off a little bit, so you see, if I do a -20, you can see it's 4,000 IP addresses, which you might need that for what you're doing. For what we're doing, I'm going to break it out. This is my standard, by the way, that for most of the things I build, I never need more than that, but you might. There are cases where you will. Okay, so we have subnet 1, S.L.A.W public 1, subnet 2, S.L.A.W public 2, create subnet. Amazon went through and created both of those subnets. Now, if I click on one of these subnets, you'll see that it's got a bunch of information in here. It shows me how many IP addresses are available. You notice it's not all of them. That has to do with reasons we're not going to get into that don't matter too much. Most of what you see here are things that are for more advanced cloud networking pieces that we're not going to get into. And so don't worry about them too much. You'll notice, though, it did automatically associate with the route table. So let's take a look at what that looks like. And so if I click on the route table, and you'll notice we're going VPCs, we're going subnets, we're going to route tables. It's like the user interface goes in order for us. Oh, and if I close that out, you'll see we only have the one route table. So this is the default route table that applies to everything everywhere. And so the routes are anything in that IP address range will route locally. Locally doesn't mean only in the same availability zone. It means it's just anything local on that network. Here's an important point about understanding route tables in AWS. Just because it says local, it's not like your home network where it blasts the traffic and anything on that network can live. That traffic will still only route from the source IP to the destination IP, and nothing in the middle can sniff it. So keep that in mind. It says local, that's common notation. What it really means is that's going to stay within this network, and it's not going to go outside anywhere else. And it has a valid route. We'll show later what you can do with route tables to actually restrict access. So even within this same network, this 10.0.0.0/16 Class B network, we could have a subnet that can't talk to another subnet. We don't need any special rules. We don't even need to use those NACLs, those network access control lists, to do that. It's just a way that, because the route table wouldn't allow that traffic, we can actually inhibit that. Okay, going back in here, and you see that route table is associated with all of the subnets. Well, let's go ahead and create our internet gateway, and then we're going to come back to the route tables, and you'll see why. So let's go to Internet Gateways, create an internet gateway, and we're going to go S.L.A.W IG, S.L.A.W Internet Gateway. Keep it nice and simple. No other settings around this. Create the internet gateway. And you'll see that it's detached. So that's really important here. It's not actually connected to our VPC. First, we create the internet gateway. Then we go to Actions and attach it to a VPC. We only have our one VPC. And, oh, interesting. I don't know why they're doing that there. And and I haven't seen that in a lot of other places, but we're attaching it to just that VPC. Actually, let's take a look at this. This is cool. Okay, so it gives you the command line for how we would go ahead and attach that VPC if you wanted to use it. All right, attach internet gateway. So the internet gateway is now attached to our VPC, and let's see what that looks like now. So if I go to that VPC, you see if I click on it again, I don't really notice much here, but look at the map down here. Notice I have my VPC, my public subnets, going to the route table, and that network connection is just kind of sitting out there. There's no connection. We have to create that connection. So let's go to route tables. And we only have our one route table still. What I want to do is create actually, we'll just leave it here as the default route table. I'll get fancy in the next couple of labs. On the routes, local traffic local, there's nothing to go to the internet gateway. Let's go to edit routes. From edit routes, again, we have that local, and we could route that somewhere else. And then we're going to go edit route. And our destination is that magical 0.0.0.0/0. This means basically it translates to the internet. The target, if I click that down arrow, it gives me the things that I could potentially send that traffic to. A lot of things we haven't touched. I can send it just to one network interface. We're actually going to experiment with that pretty soon. But I want to look for my internet gateway. So any traffic routed to the internet is going to go to the internet gateway. And I have to pick my internet gateway. And we only have the one. This is what that rule looks like. All zeros, internet gateway, local, internet gateway is going to route out to the internet. And we're going to save changes. There we go. So this is our setup. Now, one thing to understand, if you see this propagated, that means that it was something that was kind of automatically created. We don't need to worry about that. We manually created it. So the route is still valid. It wasn't propagated to us from some other external source. And that's what you can see here. It talks about all different ways. That has a lot to do when we start connecting networks together, and that's edge associations. The things that we care about at this point are the routes and the subnets. Okay, so let's go back to our top level VPC. Let's click on the VPC we already did. And actually, I'll click on it there. And we now have our resource map. And so we have S.L.A.W, and we have our two subnets, and those subnets connecting to the route table, and the route table is connected to the internet. I actually had to pause there for a moment because I don't normally use the resource map. So the dotted line is what they use for the connection to any network connections like this. So it doesn't have relevance. It doesn't mean that it's not really there. So this is great. We have our VPC. Our VPC is called S.L.A.W. We have our public and our private subnets in two different availability zones. These are sharing a route table that routes to the internet gateway. I could now deploy resources into that VPC. I could assign them IP addresses. They could talk to the internet. That's all we're going to cover for this week. Next week, we're going to get into private subnets.